Hi, I'm Tom. Welcome back to another PlayStation 2 programming livestream. Today, working more on my little side-scroller game. I think the best way to probably show what we've been working on so far is to just run it. I'm halfway through making a commit, apparently. State in heap. Last stream we were working on level asset management, but let's have a quick look. Run. At what's happening here. So this is running in PCSX2, a PlayStation emulator, PlayStation 2 emulator. Got a little platformer, cute little tile set. There's 3 different levels being loaded here, so at some point of moving across this big straight part, we load in this wavy area, and the area to the left gets unloaded, and as we move back and forward, they can get toggled in and out of memory. It's a cool little system. It means that we could have a, infinitely long world, which is really cool, and I think it works well. Just a good way of managing level data. So, that works well. But right now, the levels all share one tile set. They all share the same assets, the same graphics, but they now have their own heap where they can load stuff. So I thought, well, it'd be cool if we could have some kind of VRAM strategy so that we could have different tile sets loaded in and out of VRAM as different levels needed them. So that's the first thing we're going to tackle today. Once we've done that for a little while, and hopefully that shouldn't take too long to get working, that's famous last words on the PlayStation 2, but hopefully we're going to do a little bit of work on how we actually load these tile maps from actual data on the disk, like the actual collision maps for the level, and then hopefully, all things going well, we'll be able to start building a little editor so that we can edit these live on an actual PlayStation 2. I thought a lot about what I want the workflow to be. I was going to use tiled originally. My original checklist had tiled, and importing stuff from tiled onto the PlayStation 2, but I think it'll actually be more fun to edit directly on the PlayStation 2. So we'll try and do that. That's my vague goal. That's my vague goal for today. So let's start doing it. So I just made that commit. We've got a nice clean repo. I also made this little tile set, so we're going to go away from my nice looking tiles for a while, and I've got 2 variants of this. I've got this variant, and I've got, let's open this variant. So we've got a red tile set and a green tile set, and we're going to try and have 2 different levels that swap between them in VRAM, and potentially draw both at the same time, which is going to be very, very fun. So let's jump in and do that. Let's make a new branch. Let's make a new branch first. I think that's a good way to kick this off. We'll call it VRAM strategy. Okay, so currently to manage VRAM, we have this function called load textures. Load textures in draw.c. All it does is, where is it? Load textures. Here. Pulls a specific file from disk. It puts it into just this fixed struct, and that's okay. But what we probably want is actually to have this struct live on our level heap, right? This data that we then upload into VRAM, and we want to keep track of how we do that upload into VRAM. Potentially even do it every frame. The PlayStation 2 is fine with that. We can upload pretty much as we want into VRAM every single frame. We're not at a point where we're going to hit any kind of roadblocks there. So let's see if we can do this. Let's see if we can load our textures into this struct, upload them. The only other consideration is making sure we actually bind them properly, right? Is making sure that when we call, there's another function, I think it's called bind texture, right? Bind tile set. So we need to make sure that this is no longer just a global function that we call that always binds the same tile set. We need to parameterize this, or just call this function directly. Before we draw tile maps, we need to actually bind the textures that we're going to be using. Welcome, Doblucraft. Hello, thank you for stopping by. Are you a PlayStation 2 enthusiast? Are you a programmer? What brings you to my neck of the woods? So this texture struct is good. We can keep this exactly as it is, and actually having a VRAM address in here is going to be very, very useful because we're going to load this data, and we're immediately going to give it a VRAM address. This means we're going to need something extra as well. So in our context header, right, our level context, which has a heap and stuff, we're also going to need to have, let's make it an int. Let's make it an unsigned int. And the VRAM head is going to be, or VRAM, let's call it VRAM start. This is the first VRAM address that this level's allowed to use. And then we'll make it a site. Should I make it a size T? I'm just going to make it a size T. I think that's okay. And then we'll say VRAM size, how much VRAM we're allowed to use, and we're also going to need a VRAM head for the place we're currently up to when we're managing our own VRAM allocations. So this is like a little slice of VRAM. And maybe it's worth making a type called VRAM slice, but I don't think it's going to appear too many other places, so we'll just write it out as this triple here. But we could also, you know, potentially in draw.c, or draw.h even, maybe define something like, actually, maybe we want to make a VRAM header. Let's do it. Source of VRAM.h. Let's make a header specific for managing VRAM-like things, and we'll put a struct in here. We'll call it VRAM slice. It's going to have a size T start. It's going to have a size T size. We're not going to do start and end. We're going to do start and size, and we're going to have a size T head, I guess, for where we're up to if we're allocating things in it. And then we'll just have a couple of functions. We'll have size T. Actually, maybe we want to type. Maybe we want to type def. Maybe we want to type def foo. What do they call it? VRAM address. And it'll just be an unsigned int, right? Something like this. So instead of size T, we'll say VRAM adder T. Oops. Except we won't delete them. We'll rename them. Size T VRAM. And I know I said last stream that I didn't like the T names, but maybe I'm just going to try it out. I'm just going to see how it feels here. Probably not great style in general, but that's okay. VRAM, alloc, struct, VRAM slice. Let's just keep this as a declaration for now. And then we probably also want to make a function that can take a slice of a slice, right? That can say, okay, subdivide this, maybe cut it in half, or maybe we do that manually. Maybe we'll do this, right? Just copy everything in this slice. And copy this region. We probably also want to define VRAM max. And I think we have 4 megs of VRAM. So it'll be something like this. Cool. Cool. Now, of course, we can't use all of this VRAM just for whatever we want. Some of this is going to be taken up by the actual frame buffer, the thing that we render to. That lives in VRAM as well. That'll probably take up about 1/4 of VRAM, maybe a little more. Basically, somewhere between 1/4 and half of VRAM is going to be taken up just by the frame buffers. So we're going to have about 2 megs to work with, which is still going to be loads when we're dealing with tile sets this big. This kind of fidelity, you know, but still something to keep in mind. We can overflow VRAM if we're not careful. So this is our VRAM API. Need a semicolon here. VRAM.h. Excellent. So we've got a start, we've got a size, we've got a head. So what we want to say is if v head plus size is greater than v... Maybe I do want an end. Hold on. Maybe I do want that. If the head plus size is bigger, if it goes beyond the end of our little slice of VRAM, then we've got a problem. We want to log an error that says bad VRAM alloc overflow, and we want to return -1. Is that allowed? Maybe. Can I turn -1 into an unsigned int where it just like overflows to the biggest value? We'll return this magic VRAM invalid, because we're never going to have a VRAM address that is a maximum 32-bit int. That's very silly. So maybe we'll do it like that. Maybe this could actually... How big is 2 to the 10, 20. So this is bigger than what fits in a 16-bit int, but a lot less than what fits in a 32-bit int. So that's workable. That's something. We can use some of this range of a 32-bit int to, you know, convey extra information. There's probably some really fun tagged VRAM address stuff you could do if you were very, very clever. I'm just going to keep it simple. Use this one magic 32-bit max or max int value as an invalid address. Cool. So otherwise, we want to grab VRAM adder T, and we're going to advance the head by by the size. Beautiful, beautiful. And copy slice. All we do here is say to head is from head, to start is from start, and to end is from end. Oh, there's one more function we want, which is going to be VRAM slice reset head. And this is just what we call, this can probably actually be let's just return an int here. Similarly here we'll return an int. We just want to say if not from or not to. If either of these are null, then this is bad. Copy to from null. And we can do the same kind of thing here. If not v, reset head of null VRAM slice. Otherwise, we just say v head equals v start, and we return 0 to say everything was okay. Let's also do a null check here. Allocate from null VRAM, and then we also want to return VRAM invalid in this case. Cool. That feels a bit closer to bulletproof. I like it. And there's no funny, oh, size t, so we need to include stdlib.h. Awesome. That's looking good. That's looking like a nice solid little function. Okay, and again, we're using the bump allocator strategy. We fill up a little slice of VRAM, and then we're kind of done. So let's see if we can employ this in main now. Let's include VRAM.h. Then we're going to come down to where we do this VRAM alloc. Now VRAM alloc, this is part of draw.h, I think. Yeah, so we're going to do away with this. We're going to do better than this. All right, so we're going to make a slice that represents all of VRAM. We're going to say start equals dot start equals 0, dot end equals VRAM max. Did I call that VRAM max? I can't remember. VRAM max, cool. I'm just going to put some brackets around this to make it a little bit nicer. I think that's better. And then we're going to call VRAM slice reset head, just to make sure the head's in the right place. That's good. Is that okay? Does that build? Probably not. VRAM alloc makes pointer from integer without a cast. VRAM alloc. Oh yeah, well we now have two functions called VRAM alloc. So let's go into draw.h and get rid of this other one. We're just gonna put this in the bin. Alignment I didn't handle here, did I? Okay, I missed something from my API, and that is the actual alignment, which is going to be important, as it turns out. And we're going to do this stupid way as well. We're going to say while the head mod... There's a clever bitwise way to do this. but I don't know it. We want align, not align. So while we don't match this alignment, we're just going to move the head up by 1. And then that is the thing we return. Beautiful, beautiful. All right, so that's a lot better. That's a lot better. Now when we're in here, we have to pass in our little VRAM thing. Make VRAM alloc. VRAM alloc. So yep, so we're going to do this as well in load textures. So this suddenly highlights the weakness of the data flow, right? This suddenly... So I guess we could just pass in a VRAM slice to this for now. We're about to imminently change it anyway, so let's try this. Let's just say struct VRAM slice VRAM. So we just pass an extra bit of information through and have to include this header. And so here when we say load textures, we just give it an address of our VRAM slice. That's looking better. VRAM. I got my typedef syntax backwards, I think. And I need to remember to do this so that I've got my VRAM. Oh yep, I don't have to take the address of this thing, do I? Because it's already a pointer. Of course, VRAM alloc, too many arguments to function VRAM alloc. That's unexpected. VRAM alloc. Declared here. Ah, of course. I didn't update this as well. Alright, this is getting better. This is getting close. We also need to include p2g log.h. VRAM copy slice. Oh, right. VRAM copy slice returns an int. I changed that. VRAM slice reset head returns an int. I changed that too. Beautiful. Okay, so make C run. And that looks good. So we can still load. We still have frame buffers. Everything has worked nicely. Beautiful. Beautiful. So, how do we tear this out of the... Well, let's commit this first step, actually. Let's be sensible. Let's be sensible. Draw git add source game context git add source main.c. Okay, excellent. That's everything. Cool. So we're in a much better place to start actually managing VRAM now. So in draw.h, so basically this isn't going to exist anymore. We're going to get rid of load textures, and we're going to get rid of it by going into test entry. Now, there's this other annoying thing that's kind of come up. This other little annoying problem. Bobbius, good morning. How's it going? How's it going? So when we have actual data that lives as part of our level context, right? We do this little allocation. We had to do it first so that in our update function, we could kind of, grab it and do stuff with it. And that's a little bit gross. That's a little bit disgusting, right? So we need a way to store some generic level specific struct and remember a reference to it. And the way we're going to do that is by putting it in our level context thing. So first off, and I shouldn't have committed the level context instead, I might actually do an amend to this. Because that didn't really make sense to have. Amend. Yes, cool. So the changes to context have now vanished from that because they didn't really make sense. Struct VRAM slice VRAM. So this is like the section of VRAM that this level's allowed to use and allocate from. We're also going to say void level data. And this is going to be the thing that instead of this weird situation in this file where we had to allocate this thing first so that we could just grab it out from the start of our level heap, we're actually going to be able to store some generic reference to some pointer. And then this structure, well, whatever this points to can be literally anything. That's fine. Cool. Cool, cool. That makes a lot more sense. So let's do that. We need to include VRAM. We want to come in here and we want to say, yeah, this is nice. This is nice. We can put this data anywhere. Let's put it after we've done all of this. Let's do it at the end, just to prove that we can. So we get this data, we allocate it from, and then we want to say level data equals LD. And then we can come down here. We do all this allocation, all this setup properly. Cool, cool. I like this. I think this is good. I think this is good. So we get a level data. We can store it wherever. And so now in our update, we don't do this jank thing anymore. We say level data, which is just a little bit nicer. It makes a small difference, but I think it's really worthwhile. And so this level data, for example, we would store, this is where we would store our texture reference stuff. Nice, nice. Okay. Oh. Okay, okay. I think this is going to be good. I think this is going to be good. So. Midway level data. Okay, so let's go into test load.c. We're going to make a struct called level data. LData. They're all going to have this weird LData struct, right? And it's going to be level specific, but they're going to look very similar because all of our levels are very similar at the moment. It's going to have a struct. I think, what did I call it? Draw.h. No, it's in draw.c, isn't it? This needs to be in draw.h. EE texture. Cool, so we're going to have a texture for our tiles. And we're going to do I/O every time we load a level for now, and that's going to kind of suck. It's probably going to make the game stutter a little. At some point we can be smarter, we can say, hey, this tile set's actually shared. We've already loaded it, we don't need to do I/O again, but for now we're just going to do I/O every time. I think that's acceptable to start with. So we have the tiles, and that's it. That's everything we need. So we're going to say, before we do all of this, or after we do all of this, I guess, doesn't matter too much. We're going to come in, we're going to say, let's make a function just for this actually. Let's make a static function. Let's say static. And it's going to take a level data pointer. So this needs to be set up as well. We'll say level data is alloc from what does this look like again? Alloc from allocator. This needs to be a ref. One size of struct LData. Cool. All the manual wiring in C, right? This is how we do C. And then we'll say let's give it the whole level context. And this is the level data. Cool. Cool. Okay, so we want to go into draw.c. We're going to basically do this same thing. Load textures. We're going to do this. We're going to do this. So we put on the stack our TGA data. We're going to load whatever our tiles are called in this case. Tiles test o. .tga. Yep, that's good. We'll just return, I guess, and accept that we're probably going to blow up. This is a good comment. This is a good comment. You're reminded how much you hate C's struct noise, like the word struct. I actually don't hate it. I prefer typing struct everywhere to type defing everything, because I'm a psychopath. Because I hate fun. No, I don't know. It's kind of nice because in C there's so much magic. I kind of like being like, okay, this is a struct. It's really easy to not do this. Most code bases very strictly do not do this, but I don't know. I've always preferred it. I've always liked the look of knowing what things are. Tiles test O. Okay, now we just need to rewrite, and actually let's do a find and replace for this. So text tile set, what we're actually setting is LD tiles. And this is a dot because this is part of the struct in line. GGA pixels, VRAM alloc. Now we use the levels VRAM chunk for this. Because in the context, yeah, we have a VRAM slice. Cool. Awesome. Currently uninitialized. So actually, when we set up our context in the first place, I guess we need to take struct VRAM slice. Right, we need to take the section of VRAM that the game is allowed to use for miscellaneous stuff. At some point, we'll take a section of this for things like shared fonts and shared assets, but then there's a chunk left over for the 2 level buffers to use interchangeably. Beautiful. And I guess we'll make these non-contiguous for now. So we could load both levels into VRAM at the same time. I think that's okay for now. At some point, we might make every level control the same section of VRAM, and then if we want to draw both levels at the same time, we just have to upload everything into VRAM every single frame, and that's okay. But yeah, you're going to agree with... Yeah, no, it's fair. I don't know. I literally don't know anyone else that writes C like this, but I kind of like it. I kind of like this style. Your mileage may vary. Cool. Okay, this is good. We don't have a return value, so we're just returning. So we can set up the texture. Nice. Now, there's one other thing we're going to miss if we want this to really work. Actually, let's not get too distracted. I'm really jumping all over the place today, as always. When we context init, we now take a struct VRAM slice. This is the section of VRAM we're allowed to use. And we're going to say VRAM... We're going to get the size of the section we're allowed to use, which is going to be VRAM and minus VRAM head. Right, so where are we in VRAM currently against where are we allowed to allocate to? And then we're going to divide this by level max, so we're going to say VRAM VRAM size divided by level max. So we're going to share it between each of the levels. VRAM start equals. Okay, so now we're going to need to do a thing as well. We're going to need to say VRAM add a T, VRAM head is VRAM head. We need to do it like this. So we're going to say the start is at VRAM head. The end is at VRAM head plus VRAM size. And the head is at VRAM head. I should actually probably put these ones next to each other. Beautiful. And then we need to say VRAM head plus equals VRAM level size. And we need to say greater than equals here as well. We can't write to the 4th megabyte byte, the 4th megabyte. We have to stop one short, right? Because that's how sizes work. So if we say we can write up until VRAM head plus VRAM size, then the next thing is allowed to write up to VRAM level size. Okay, cool. I think that works. So all I should have to do here is pass in the VRAM slice as it exists. Infinite coder 4:37 a.m. Going to competitions in another country. So like you're mid-travel and it's a weird time of morning. That's awful. I hate that. Thoughts and prayers. Good luck. Okay, so this is going away, and when we call init now, we pass in our VRAM slice. And that's going to set up our levels with VRAM stuff. But this means there's something else we need to consider. Actually, right now there isn't. No, okay, there is something we need to consider. And that is that when we draw these now, we need to make sure that the bound texture actually relates to this. So we basically need to say like maybe CTX levels 0. If CTX level 0 dot pre-draw, then we need to call the pre-draw function. And I think this just gets called in a vacuum. I don't think we have to pass any state to it. Maybe let's just pass game CTX to it just in case. But basically, this is a function that will make sure that when we do the draw, everything's going to be in the right place. This still isn't quite spot on because we might have... This basically says all the sprites we're going to need have to be loaded right now, right? We're about to draw a tile map. Load everything we need for it. The reality might be more complicated than this. There might be more nuance here than I'm giving this credit for. But we'll start with this API. I think this is okay. Yeah, we'll just say we'll just give it this weird pre-draw thing. This is getting to be a very fat struct, and that's okay. We have a cleanup function. Yeah, if I want to swap stuff in out as I'm drawing, it won't be enough. You're absolutely right. Also, if I want to... So, I mean, this works... You know, this assumes the only thing that's going to change is drawing the tile map, but they may have other graphics for things that aren't part of the tile map. So... I mean, I guess there's no real harm in just making this a draw function, right? Like maybe we make the level itself responsible for this. This moves a lot of responsibility into the level and means there's probably going to be a lot of duplication. But I guess that's okay. This could mean things like levels could have multiple layers of decorative tile maps. Basically, we're moving towards a world where these are just transparent blobs of behavior with a bit of state, and the actual tile maps and stuff, like because the data already exists on the heap. Basically what I'm pushing for is moving all of this into the level data itself, which makes quite a lot of sense, really. Why is my floating windows are floating away? Maybe this is maybe I need to bite the bullet and do this. So this would be a level draw function, which takes a game context and a level context. I think Bobius is right. Bobius has convinced me. Code duplication has consequences. Bloat's not super friendly. This is true. However, what I mean is, like, if I have 10, like, only 2 levels can be resident in memory at a time. So cache unfriendliness isn't really gonna matter. It's like 2 times n instead of n, which can be significant, especially on a hardware constrained system. Ideally, a lot of... Like, I can actually share code, right? I'm doing everything in this very static way. I can actually have 2 things call the same draw function. I could do that. I think this is the direction, potentially. I just want to be able to do the VRAM thing, basically. I want to take advantage of VRAM a little bit better. And I think this is the only way I can do it without putting a lot more complicated state inside this level context, which I don't want to do. I want them to be a bit more flexible. So I think I'm going to do this. I feel like it's been going in this direction all of last stream, and this is probably just another step in that direction. Maybe it's a mistake. I don't know. We'll find out. We will find out. Okay. Okay. Yeah, I think we're good. I'm nervous, but I think we're good. Decoration, collision, draw. Okay. Yeah, update, draw. You missed the last stream. The last stream was, just setting up this level swapping stuff. So basically, the game context has 2 levels. It can load in kind of level A and level B, and then while you're in level B, you can load a new level into the level A slot, so you can kind of do this infinite scrolling. That's the goal. And it's fun to support that, but I want to do more advanced resource management. But because the PlayStation 2 is weird, I think I basically... Either I build a much more complicated VRAM system, or I bake a bunch of actual logic into the level itself. Ideally, levels won't be made up entirely of code, like I'll be able to load a tile map from disk and stuff, but for now, having everything in code is kind of a nice way to explore, and having these structures in code means that I can write a version of it that loads things from disk. That's fine, but it's got the flexibility that if I need a snowflake, I can hard code it as well. And I imagine this is how a lot of PlayStation 2 games work, right? They're data-driven until something broke, or something wasn't fast enough, or something, needed to use VRAM in a creative way, and then you could drop in and just hack through it if you needed to. That's how I imagine people would have actually done it, because things like, you can do weird stuff with VRAM, just because you're constantly streaming in and out of VRAM mid-frame. So like, why not write weird code that takes advantage of it? That's my feel. That's my vibe. So let's try this. Let's see what happens if we do this. So let's get rid of this draw tile map for now. And let's do this again, but for 1. Sometimes I loop, and sometimes I hard code this, and I don't know. I'm kind of on the fence about if I would ever have more than 2 things. I've written some code to support it, some code doesn't. Again, it's a bit of a mess, but we'll work it out. Okay, so let's say we have a draw function in entry level. For one thing, this should go somewhere else. This should go somewhere else. Actually, I was writing it in here for some reason. This was not the level I meant to write this in, but that's okay. This is going to be very, very similar. Very, very similar. Okay, so this, again, very similar to what we had in context.c. We're just going to do this, but we need to make sure the texture is actually resident first. Oh no, it's resident. Yeah, we'll upload it, and then we'll bind it as well, every single frame. Okay, context. So this is now just the level, decoration, and the camera. Yeah, the time pressure working commercially means they do everything the dumb way. Yeah, this is true. And I feel like this is the path that I'm trying to follow as well, right? I could do this smarter, but sometimes the path of least resistance is there for a reason. So level draw equals draw. We're going to copy this function. And again, you know, this function actually doesn't need to be special. Maybe source levels, like maybe this just needs to be draw decoration. Maybe this function can actually be shared. Oh, Kaze Emanuel's Super Mario 64 videos are incredible. The latest one about optimizations that he just switched off and how much that improved the speed. Like he just disabled things like loop unrolling and, you know, it sped up the game. It's really, really insane. Like, the things they thought were making the game more optimized was actually slowing Super Mario 64 down a lot. But that was, I mean, making the first game or like a very early game for new hardware is always a bit of a shit show. Early PS2 games have that problem as well. I imagine by the end of the console's life cycle, you're not going to find that kind of thing. So it's partly doing things the dumb way, and it's partly not having the tools to do things the smart way. Yeah, the N64 sucks with unrolled loops, because the instruction cache is much more important, right? Good cache alignment. And one of the things Kaze Emanuel talks about in his latest video is that sometimes you make a change that should make your code faster, but it just realigns the code in a way that's not cache friendly, and your code gets worse. And he has the tools now to examine that and work it out and just try, like, you know, just kind of like churn through things and find the best way. But back in 1990X, they probably didn't really have the tools to work out why their instruction cache wasn't being utilized, like why their change impacted that. So they probably had to do a lot more by guesswork and vibes. So it's not surprising Super Mario is how it is. Today's optimizations are bad for old hardware. Yeah, your optimizations have to suit the hardware. Modern processors have very different profiles for a lot of things. You know, we have gigantic cache. We have like three levels of really big meaty caches. And I mean, hold on. So MIPS 59. So this is R5000. This is the series. Is it R5900? This is the PlayStation 2, right? Yeah, R5900. R5000. Custom instruction, cache arrangement. Okay. So I guess I need to look at the E specific page. CPU core. MIPS 3 and much of MIPS 4. It's one of these funny in-between processors between MIPS 3 and MIPS 4. 128-bit data. SIMD. Introduction of SSE. 6-stage integer pipeline, 15-stage floating point pipeline. That sounds long, but it's really not. Fixed function controller, AL, 2 64-bit ALUs. Where does it talk about the cache? So yeah, 16 kilobyte two-way associative instruction case. Non-blocking data cache. Scratchpad RAM is the other thing that I really need to utilize more in my PS2 code. Data cache is virtually indexed. Yeah, but basically, yeah, it's like, compared, how much does the Nintendo 64 have? Like, even from the PlayStation 60 and N64 to PS2, it's a real big jump. But just the numbers never tell the full story either. Hardware. They probably, hold on, there's probably a page just for the hardware, right? System bus. RAM. No, there's no specific. This is less detailed somehow. MIPS. Skill design. Oh, wow, is that actually the same? Hold on, is that the same cache size? Two-way non-blocking data cache. Yeah, wow, that's the same size. Scratchpad RAM? Scratchpad RAM has different properties. What does this say? in memory. Scratchpad RAM has different properties when being used with DMA, basically. It has... Let me... Hold on, let me find quick access, SPR, data scratchpad. Oh, cool. This was actually all in the hardware manuals as well. Data bus, main memory. Yeah, so telemetry transfer data, main memory, peripheral processors. You can use the main thing I've kind of seen Scratchpad RAM used for is, for one thing, you can DMA from RAM into Scratchpad RAM and vice versa. So if you DMA, for example, right, you can have this kind of pipeline. You can DMA, from my understanding, this might be a little bit incorrect. Everything I say might be a little bit incorrect. So let's say you have the CPU, this is the EE core, and you have the VRAM somewhere here, right? Let's call it the VIF, right? And you're gonna DMA, so like our RAM is, you know, kind of attached here, right? You could copy, hold on, this is meant to be GIF. Right, so you have the graphics synthesizer interface. So you can do a DMA transfer into RAM. Also, where did my M go? Right, so this is a DMA. Say you read some stuff from VRAM back out, right? You copy it into RAM. But while this copy is happening, you can DMA from Scratchpad to VRAM while interacting with regular RAM from the core, or vice versa. Yeah, that's probably actually the better way to show it. That's probably the simpler example, right? Is where you do it this way. So Scratchpad, yeah, just kind of exists separately. It has its own little channel, I guess, for this. So if this is a Scratchpad, like this can go out while you're still doing stuff. You're spot on. You got it. You got to my conclusion before I did. A bit shorter-winded, which is really cool and useful, right? It's just this special little region. Channel whose transfer is memory. Channel whose transfer source is memory can select main memory or Scratchpad, SPR, Scratchpad memory. Yeah, so it's really useful for transferring stuff with good properties. Cool. That's not the right buffer. Okay, so I'm going to try and move some of this level stuff that's copy-pasted into its own shared file, because I think that's better. I think that's going to be a lot nicer. You don't want to be locked out of RAM while DMA is going on. Exactly. The more things you can do at once on the PlayStation 2, the better. So I leave a lot of performance on the floor by not taking advantage of this. It's actually a really big deal. It's one of the biggest things I need to look at. That's the wrong file. Load.c. Cool. This needs to be a pointer. Other than that, we're good to go. All right, awesome. So then we also need to include nice. Okay, I think that's everything we need. So now we can make this a little bit simpler. We can say draw level, draw decoration. Cool, so we can reuse. It just, these files get a bit smaller, a bit easier to manage. It makes me happy. It makes me very happy. So now when we say set wall, we just say level, set wall. And these are just placeholder functions anyway. We're not going to keep them around too long. And once we have code to load these maps from files, that can be shared between levels as well. That's going to make things simpler too. That's going to be good. That's going to make things really good. Okay, beautiful, beautiful. We'll load our world position as well, and our size and stuff. We'll load a couple of numbers from a file. That'll be a really huge, hard to comprehend how huge that improvement will be. All right, I'm gonna take a quick break. I'm gonna take a quick breather. My apologies. I'll be back very shortly. I'm not gonna do a full Quake BRB. I'm just gonna do a quick one. All right, back in a sec. All right, we're back. We're back. Life is good. So we've got this thing. We're gonna do this. We're gonna do this everywhere. Except the only problem is. So I forgot the whole point of doing this was that it's not shared because we need to upload the thing that only we know we have, right? So that's a bit of a problem. It's a bit of a problem. I guess there is another thing we could do to make this a little bit more automatic. We could give every level... Okay, actually, yeah. I'm gonna stick with every level having its own draw function so that if it chooses, it can do things in a very different way. However, I'm gonna remove the need for a specific structure. I'm gonna give every level in its context. It's gonna just have some space for some textures. That's gonna make it simpler. It's gonna make it a little better. Yes. Okay, this is good. So we're gonna say struct level texture. And a level texture is gonna be a very thin wrapper. Level texture. Right, it's gonna be a very, very thin wrapper over a EE texture. Struct. And it's just gonna have one extra field active, right? To say if it's actually being used by this level or not, and if it isn't, we just ignore it. It basically just doesn't exist. Cool. And let's say we give everyone 3 textures for free. These textures take up basically no space, right? This is pretty much free. We could give them 10. It would take up essentially no space. The important thing is that the level itself, when it loads this, it puts the actual pixel data in its heap. This is the important bit. This is what takes up space. The actual, like it's not very... Oh no, hold on. Where does this come from? Hold on, TGA from file. This just calls malloc, doesn't it? Fread. TGA from file out. This is on the heap. TGA pixels. Wait. Pixels. Pixels calloc. Okay, so we need to pass in an allocator here as well. That's okay, we can do that. So then the pixels will end up on the heap, not in a random point on a different heap we don't care about. But that will make all the difference. That will make all the difference. So we can tolerate just having some header data in here, right? So if I look at draw.h, this is 4, 8, 3, 4, 5. I mean, this is 20 bytes. This is 20 bytes. Nothing. We don't give a shit about 20 bytes. We don't lose sleep over 20 bytes. Okay, this needs a semicolon. So we're going to keep this draw function. We're going to say levels shared. We want to say for, well, hold on. We need context.h. We want to say define level texture slots 3. I equals 0, I less than level, texture, slots. Except we don't know which one relates to this, so this still needs to kind of be a special case, right? Does this give us any benefit at all? Did I do this for no reason? Is this worse than what I had before? I don't think it is. No, I do think it is. I think that's actually worse than what I had before. I'm going back. I'm going back to everyone being a snowflake. I had to go the long way there, but I'm going back to everyone being a snowflake. Did I say this was an int or a void? I said it was an int. Draw. Okay. I'm flip-flopping. I'm flip-flopping. So we load this into level data, which, did I delete all the level data definition? I did. It's so dumb. Let's go struct ldata, and all this has is a tiles struct EE texture tiles. An EE texture, like, it just represents EE in this case being the emotion engine. I didn't really explain this name before, but this is just how we represent a texture on the CPU that may be uploaded to the graphic synthesizer VRAM at some point. Okay, so when we draw, we need to say, so our tiles are in here, so we want to say draw up maybe bind texture. What do we do at the moment? What do we call this at the moment? We call it bind tile set. And what all bind tile set does is called draw 2D actually, I think. Bind tile set, yeah. So let's now make this take a struct EE texture T. And we're going to say everything's PSM32. We can change that later, we can thread that information through later, but it's not too significant. This is now called draw bind texture. Struct ldata. And then we say draw tile set. That's it. That's all we do. We draw the decoration map. We use the camera from the game context. Beautiful. So we make sure that the tiles are loaded and then we draw them. Easy. Easy game. Easy life. Did I look at any of the Reddit posts you linked on Discord? When did you link them? Which channel? Oh, yes. I saw the Google Japan keyboard. How much earlier? I don't see him. I don't see him. Reddit post linked on Discord. I don't see any Reddit posts. Was it in my server? Am I going crazy? Okay. In general. Oh no, yeah, I did read them. They were long. They were I didn't read them all in detail, I'm gonna be honest. Yeah. They're impressive. I appreciate people who take the time to write answers like this. This is not me, but they're good. They looked high quality. Like, I like reminding people that learning to code is hard, because people like to look at, someone like me, not to blow too much smoke up my own ass, but I'm a good programmer. I think I can get stuff done. People who are like, wow, like, I haven't learned how to do that. I must be really dumb and bad at programming. And it's like, hold on. There's, like, it glosses over the fact that I spent 10 years of my life writing code every day. Yeah. No, it's good. It's good. I hope the people you responded to read them in more depth than I did. That's all I'm gonna say. Yeah, I do want to write more, actually. I feel like I really should. It'd be good practice. We need to load textures. Load textures. Wait, I have not set up. Oh no, I have here. Okay, so we can say, this is fine. So we can say load textures level. I like the order we do this in doesn't matter anymore. This is nice. This is nice. So load has tiles, textures has tiles. Now all we need is for test entry to have tiles. For one thing, set wall and set floor. It's gone. It's out of here. Level set wall, level set floor, level set floor. This is going to look so much cleaner once I don't manually populate my tile map like this. Also, this is going to be really ugly, but that's okay. This is going to look so disgusting. It's going to be really funny. Okay. Level data. Okay. So there's something else I'm forgetting in levels. I forgot to say level set floor. Cool. Awesome. Whew. Yeah, I find when I write, either I write like 2 sentences or I write a novel, right? I don't have that. Some people have that really good in between. They go into enough depth without going into too much, but can also explain things. I really struggle, and this is why I want to try writing more. Like, I want to practice explaining things in the appropriate amount of depth. I struggle with this as well. Once I get on a roll, and then I read it back and I'm like, am I just talking shit? Does any of this matter? Does any of this mean anything? Alright, so I want to copy this bit from this file. I want to put it into test entry, because this is kind of like it's called entry because this is like our entry point, right? This is where we start the game. This is where we initialize. Okay, I need to initialize the level data, which I can do down here, which is fun. Or up here. Let's do it here. Let's do this. And do I just build this and see what happens? I'm pretty sure I've goofed a lot of stuff here. Okay, this is good. This is good. This is easy. Draw.h. Yeah, it's better to give... It's better to give a little bit too much information than not enough. Like, you don't want to make assumptions. And also, I think very importantly, OpenAI is probably very happy for all those words to mulch into their gigantic, opaque blobs to regurgitate forevermore. You've got to think about these huge corporate companies that want to consume as much text as possible, right? Write more words online. It's always going to be a good decision. You're their favorite kind of person. That's extremely bleak. That's extremely bleak. Alright, load textures. We've got conflicting types. That's because in draw.c, this function load textures, upload textures. Oh yeah, we're not uploading them ever. That's kind of a problem. It's kind of an issue. Okay, so this is the next thing on the chopping board. We're going to have to deal with this. How do we know? Keeping track of this is hard. I think I'm literally just going to call this at the start of every draw for this thing. I think this is my new strategy for now. Level entry. Maybe when I say bind. Not necessarily when I bind. When I first try and draw this thing, I just wanna upload it into VRAM. LD tiles. I just want to make sure it's in VRAM. I just want to really make sure. And the PlayStation 2 is literally fine with this. It actually has no problem. This would be better if it was in scratchpad memory. Trying to learn C++ when you were 12. Where do we even ask questions? Yeah. That's the C++ experience even today, I think, though. C++, I never made any progress with C++. Java SP, thank you so much for following. Welcome to the PlayStation 2 Homebrew Club. We're getting really close. 795 followers. We're real close to that 800 mark. When I hit 1,000, I'm gonna do a music live stream. I'm gonna play some flute for you guys. It's gonna be fun. Do some piano, do some singing, do a bit of a variety show. A couple of people have been asking about it for a while. It'll be fun. Spent 2 years in that studio. Yeah, no, C++ is an absolute nightmare though. I bashed my head against C++ for a while before I gave up and went to Java, and Java was where I started actually writing code that made sense. Python as well. I was really lucky. My older brother, when I was like 5 or 6, my brother, he's much older than me, he was at uni. And so I was maybe 6 or 7, and I was interested in tech. I must have been over 7 because I had my PlayStation 2, and that kind of led me into like games and wanting to know how they worked. And my brother was like, "You should learn Python," and so I tried learning Python, and I didn't get it. But it was one of those things where it's like I gave up; it was too hard, and then I came back and I did it again, and I got a little bit more, and then I hit another roadblock and I gave up because I was doing music. I was trying to be a musician from a really young age, and I would just give up. And then sometimes I'd come back for a little bit and I'd get a little bit more. And then by the time I dropped out of music, I was like, oh shit, I can write code, right? This is great. I've got a job. Unlike, kind of depressingly, unlike all of my friends, I actually got a job. Which is good. So these bind tile set, these none of these functions exist anymore. These are all dead. They're all dead. They're all gone. So where are we? Bind tile set? Did I already delete these? Yeah, I guess it was. Oh no, here we are. Upload textures. Okay. Upload textures is gone. It's gone. It's done. Okay. And I think in context.draw I was calling bind tile set, which is now also gone. So what happens if I make now? TGA is not known because I didn't include TGA. Except this is ... TGA. Oh yeah, and we're not actually using the level heap. That's okay. We'll tolerate that for now. We will tolerate that for now. Test. Edge. LD undeclared. That makes sense because I need to say struct LData LD is level data. I suspect that problem is going to persist between all of my files. Yes, of course it is. And then also test entry. So this is the downside of everything being a snowflake, right? But we're not going to do this long term. This is just a test to make sure the machinery works. We're going to do smarter stuff eventually. Grade 9 computer class had VB6. Grade 10 introduced Java. I didn't have any programming at my high school. I don't think. Maybe I just missed the classes because I was so laser focused on music. But I did literally 0 programming in high school, which is really funny to me because I became a programmer. But like I was in the first. Oh, actually, I probably shouldn't say that. That's too much identifying information. But while I was in high school, we got access to certain resources for the first time as students, technology resources that had not existed before, and like in my whole state, right? And we didn't get taught any programming. It was kind of stupid. Draw upload texture. I need to include PS2 draw. Oh, and we also need to do the stupid, we need gspsm.h. Actually, where was that? This isn't hard. Teachers don't know shit about writing code. I've been running programming sessions in schools, right? One of the classes we've been working with, the teacher is really fantastic. She's really switched on. She's really enthusiastic. She wants to teach these kids coding, but she just doesn't know anything about code, you know? She hasn't got the resources to do it. And that's why it's been cool to be able to go and help some of these kids out, because some of these kids are really interested in computers, and with a little bit of a push, they're really, really into it. But they just, you know, the teachers don't have the resources. Super, super common. Draw bind texture. I was gonna not delete these, wasn't I? Whoops. Where did I go? I accidentally moved that to a different workspace. Okay. I was gonna not do that so that I didn't have to import GSPSM. This is better. This is better than what I had. We're going to keep this draw header around. It's actually got some utility still. And this is going to be draw upload texture. Oh, but this is a name clash. This is stupid, but that's okay. He was a nice teacher, interested in coding computers, didn't have prior knowledge. Yeah, and absolutely, right? This isn't like throwing shade on any teacher that is struggling to teach code. Like, it's a resource problem. The fact is, you know, there aren't good tools for them. Like, learning to code is hard, and of all the other things a teacher has to do, you know, the more you can like take it out of their hands. I've been trying to build something. I'm building it off stream. I'll show it on stream one day. It's the end goal of my virtual machine programming language. It'll come out at some point, and I'm going to build some of it on stream as well. I just want to do some of the nitty-gritty Golang wiring. I'm doing it in Golang. I was going to do it in Rust, but I thought I just want to do what I know a bit more for now. Okay, so this is better. So I'm going to go through all of these levels again. And this has been a really chaotic refactor, but I think we're honing in on something good. TGA from files. So we're going to say draw upload, EE texture. We're not going to care about any of this anymore. We're just going to pass a pointer to this thing in. And this is better. This is way better. This, oh, mwah, mwah. Okay, test. Yeah, hopefully I can sell something to a school. That would be nice. Don't know if it's realistic, but that would be nice. I also like building things at school scale, right? Because if you're like, well, I want, you know, every school in Australia to use this, you're still kind of like, this is small enough that it could run on my box that lives under my desk, right? I wouldn't do that because I don't have a UPS and stuff. But, you know, it's like one server scale. You don't need to scale up to like 100 gajillion users. So I can actually get rid of some of these imports now, which is fun. PS2 draw, we don't need anymore. We just need draw.h, test, entry. We just need, I didn't even add it here. Okay, we're getting close. We're getting close. Level set wool. Level test load and net. That's okay. I'm just going to return this. Return 0 this. Level set wool. Levels.h. Levels.h. We did not put these in the header. And really, these probably shouldn't be in the same header that other things, like these are kind of, you know, internal. But that's okay. Draw defined but not used. That's going to be a problem. That's going to be a problem. Level draw equals draw. And we're going to have to put this in all of our wonderful functions. And test, load. Load already had this because that was the first one I added it to. VRAM, not a pointer. Runs on my Raspberry Pi scale, yeah. Maybe like somewhere between runs on my Raspberry Pi and runs on my home server scale. Somewhere in between those two, right? Honestly, it probably is Raspberry Pi scale. It just might have some issues at, I don't know, peak moments. But again, the other fun thing about trying to sell to local businesses is your support hours are 9 to 5 weekdays, right? I guess because it's school kids, they might be doing homework on weekends, right? But it's, thinking about most kids, there's probably not going to be a lot of weekend homework to support. Your load is going to be very regular. It's bad if it goes down, but it's not. You want to fix it quickly, but it's not going to be the same as like your airline software breaking at 3 a.m. No return statement. We can return 0 here. What's next? This needs to be a pointer. So my last job, we only serviced just Australian logistics businesses. So that meant that, hold on, was that unused? Defined but not used. Let's actually fix that. We only dealt with Australian businesses, so on-call hours were freaking great. Sometimes you cared, once I had to stay behind for like an hour because we had an outage, but draw tile map, that's okay. That function no longer exists. Sea levels, okay. Now this is also important. We have to pass in a pointer to this, but yeah, like dealing with local businesses is highly recommended if you're doing software. Your support until 9 p.m. Rotate weekly. You need the money. I mean, like, seriously, like, it depends how often it goes off, but just being on call, like, getting a bit of extra cash, I never minded it. I never got called at 3 a.m. when I worked at the bank. That was the one. When I worked at the bank, and it was like, something went wrong at 3 a.m., it had to be fixed at 3 a.m. I never got called. The other guy on my team, he had to deal with some 3 a.m. calls, but luckily, I never did. Okay, this is gonna break in all kinds of unexpected ways, also because we'll draw decoration. Oh, I've got these ghost functions hanging around. Levels.h. This function no longer exists. Draw decorations. I guess it's in load.c. Nope. Okay, what else was not existing? Draw decoration, test entry. This one. Okay, there we go. Now we're building. Now we're running. Excellent. Excellent. Bad dimensions. That's unexpected. Texture upload overflow. Okay. I've got a creative solution. 128 by 128 may actually just be too large. So here's what I'm going to do. Here's my revolutionary solution to this. Just avert your eyes. This isn't how numbers work, but that's okay. We're gonna export to this, and then we're gonna, I really hope that remembered my RLE. Yeah, I remembered my settings, good. I don't support run length encoding. Okay, let's try this again. Upload overflow. Weird. Okay, we're gonna have to work on this. 3 a.m. is not gonna be answered. Yeah, if you're only on till 9 p.m., like 9 p.m. is not the worst. And like I said, I never minded getting in a bit of extra money. But I also, like, we had good testing practices. If you worked with a questionable team that were, cowboy coders and deploying weird stuff, then you don't want to be the on-support guy. Okay, so I need to work out where this error is even coming from. Draw2d.c, bad dimensions. These are the same dimensions as the texture I was already uploading, right? Oh gosh, don't look at my file system. I don't know what I have in here. I don't want people to see it. Whatever I'm selling, I don't want you guys to buy. Okay, so tiles.tga. So what's the difference, right? This is a true color TGA. It's the same size. So why is it freaking out? Why is it angry at me? It opens this okay. It does it? Maybe it doesn't. Is this a real file descriptor or is this a bad file descriptor? I'm never sure. Hold on. Why is it putting this slash here? I don't think that's right. What's this? I wanna. What's going on here? Entry.c. Why is it putting the slash? That's not correct. I don't think that's correct. Let me double check. Let me check my repo. Source. Do I even... Yeah, I got this in a working state here, right? So what was I in draw.c? I need to push. I'm well behind here. Load texture, host tiles.tga. This was... What's going on? Why is what's the slash doing? This is an unwelcome slash. Well, actually no, but it has to be reading the file, right? Because it gets the size correct. So I guess the other way to test this is to change the name and see what happens. Bake a bad name into it. Okay, no, so that's a negative number. That's fine. Okay, so that slash is innocuous. That's okay. X-ray assistant roof the dev team promotion. Senior tech support specialist. That's a good raise. I would take that. That sounds very official, right? That sounds like something you could put, you know, on your badge, right? You need some kind of like fancy entrance, right? You're on a plane, someone's like, is anyone on this plane a doctor? And you're like, no, but I'm a senior tech support specialist for a vet. Feels very official. Feels very official. Bad dimensions. Okay, so what triggers this? What triggers this? We need to dive into my code. Draw2d.c, bad dimensions. If EE VRAM size greater than bytes, what's bytes? Bytes. EE VRAM size. What's bytes? Is bytes the buffer? Huh? Why do we do this check? Sorry. Upload texture. Size. The size of the texture. Oh yeah, and we only deal with PSM32, so that's fine, that's fine. That's odd. That's not what I expected here. So what goes into the size of the texture when we load it? Let's look at entry. What goes into the size? Pixel size. Well, this isn't right. Well, I guess it is. I guess it is. This check seems entirely stupid. Because we never use it again. Size. It's only used for this one thing. So I'm just gonna do this. Okay, so we no longer overflow, but we have an exception. We have a null pointer. Okay, okay. This is okay. This is fine. This is fine. The company got acquired by Mars, who owns too much of the pet food and vet market. Ain't it always the way? It's always, everyone's always conglomerating. Everyone's always globbing together into these huge amorphous blobs. We're just gonna put a little marker here. So let's debugger. We're gonna step through this with, what's my file called? Game.elf. Of course it is. An actual to-do, very rare for me, very unusual for me. Okay, so I wish I could break on a trap, but I don't think that's possible. I think if I run, it's just gonna null pointer exception. Although it does say 101E020. Let's try going here. And this actually, 101E20. 101. Wow. Wait, is this actually telling me where something went wrong? That's so unusual. TEQ. What's TEQ? I've never seen this instruction in my life. This is unexpected. TEQ. Actually, hold on. I can go one better. I can actually go straight to the source. Oops. EE core TEQ. Trap if equal. Huh? What's this? Why am I trapping? How did this instruction get here? Is this the div problem all over again? What is this instruction? Put tile. Put tile. What is this? How did this happen? Why? Okay, what's our cool stack? Let's break on this and reset. Okay, what's our cool stack? We've come from the middle of draw tile map. That makes sense. But why is put tile trapping? I don't understand how this function has been compiled like this. Oh. Okay, hold on. Whoa. Somehow that still compiles. Because this still exists. Okay, let's make now. Now there's a problem. Now we've got a problem. Now we see the cracks. Now we see where this came from. I'm still confused by why this function was getting compiled like that, but that's, I guess we'll survive. Tiles per thingo. Cool. Okay, nice. Put tile. Nice. Draw tile map TM. We also probably want to give it a texture, maybe. We're going to change this a little. And now when we call put tile, we're going to give it the texture as well, except we already used. Let's call it text. Okay, I think this is good. So now when we go into anything that says draw tiles, which is going to be all of these, draw tile map, we just need to give it a texture as well, and this is going to be LD tiles. Okay, test entry and test load. Okay, we're getting better. We're honing in on this. Actually, no. Yeah, let's keep put tile public because I think other things might want to use it. Struct EE texture text. Struct EE texture text. Okay, more things are parameterized on the actual texture. Make C source run. Okay, this is progress. This is progress. We can see there's actually 2 tile sets being loaded here, which is cool. And we're gonna see that there's it's swapping between them. So this is actually progress. This is something. Yeah. I've seen worse. This is fine. I don't know what the problem is. Okay. So what could be going wrong here? What could be happening here? I mean, you can actually see that it works, and that's incredible. I will kind of take that, even though we're in Bizarro world. Okay. I don't know what this is. Actually, I don't think this even shows up on stream, right? They're alternating frames. There's this weird garbage. But if I pause at the right time and then play again, I don't know. Maybe it does show up. So what is this? What's going on here? Oh boy. So garbage like that makes me think that potentially maybe we're over... That doesn't make sense. I don't know what that is. Let's try and fix something smaller first. We'll worry about that garbage. Hopefully that just goes away magically. Is there something we've hard-coded? Yes. Tiles per row. No, that's okay. We're assuming it's an 8x8 tile set. This is a 16x16 tile set. So we're gonna recompile this and it's gonna look better. Except I want to make C. I don't know what make -s is. I don't know. Maybe that's garbage. Okay, that didn't fix it. That looks better, but it didn't fix it. Okay, that's okay. So this needs to be a parameter of something somewhere. That's okay. Okay, nobody panic. What if I go back to this? This is gonna say it overran again, didn't it? Upload overflow buffer. What's this about? Can I just add 1 to this? No. I wish this actually printed out the thing that the numbers that were relevant to this overflow. Because that could easily be causing something, but I don't think it is. I don't think this size is ever actually used, right? These bytes. This is just this little check. But like, why do we ever check this? What is this block? Why did I write this? Why did I write it like this? What am I doing? This is meant to be the size of the texture. Oh, this is the size of this texture. So this is texture size, right? So what we're saying is, if we're gonna try and read more than the size of the texture, then we have a problem. And actually, that sounds like a bit of a problem. That sounds like a good way to end up with some garbage. So, texture size equals, let's put a relevant thing into our print statement. I think I see a problem here. I think I can sniff out a problem here. So let's make this export platform equals PS2. Cool. Okay. That's okay. That's fine. libp2g, we're going to put that in source lib. Cool. So now, if I go back to this bizarre thing, I'm going to get rid of my to-do. Bobius was so proud of me for writing a to-do. We're gonna do a clean and then a run, because we want it to properly re-leak against that. Okay. We're gonna just copy this over again. There we go. So at least this tells us now how big the texture is. First time in your life, all your requests for to-dos. But it's gone now. It's gone. But I guess I came back around to it, so it was worth it. Okay, so what is 25... where is this? Python. So 64 times 128 times 4. And both of these textures, or one of this texture has this problem. No, but these are two different textures. These are two different textures. That's when we upload it. So indeed, right? This is how many bytes we want to read, and this is how big our texture is. So I'm just gonna export as tile 0. And indeed, it's 24.6 kilobytes. But there shouldn't be any RLE. So we're going to replace this one. No RLE, top left. So what's this number divided by, for example, 64? What is it divided by 128? Divided by... Well, what is it divided by... what's this? This is 2 to the 16, right? No, it's 2 to the 15. So it's 75% of the size we expect. That's, Where'd the other quarter of this file go? What's happening? It's always something, isn't it? File source tiles test o.tga. 75% as big. It's a 24-bit per pixel file. Ridiculous. Absolutely ridiculous. So if I add an alpha channel, and now I export it again, no RLE top left, and then let's pick a nicer color than that garish green. Export as tile test 1. That makes so much sense. And this is one of these things, right? This happens when you have to do really manual file I/O on these old consoles. Strange things happen. There we go. So we still have this weird ghost thing. And also we're drawing these background tiles that, like in the other tile set, these were just invisible little things. We can also see there's this slightly weird... Our UVs are sometimes a little bit too aggressive. I think we need to add a very small offset to them. But we can see we've got 2 tile sets. 2 competing tile sets. Now, unfortunately, we have not we have not fixed the weird flickering ghost. I don't know what that is. Actually, I do know what that is. Because we're interlacing, right? So this is a weird artifact that's only drawn on other frames, right? So it's not drawn on this frame. Yeah. It's literally just the texture, but it's the texture swizzled, right? So this texture is here. Sorry, that was just a mysterious noise in my driveway. Sounded like someone just hit some... Hold on. Yeah, that was weird. So it's this texture swizzled, right? So it's like this block and then this block, and this is how the graphic synthesizer does memory, right? So 1, 2, 3, blah, blah, blah. Yeah. So it's... Okay. So this tells me what has likely happened, but this still doesn't make sense. It's like the frame buffer has the texture in it. It's like the frame buffer points to part of the texture. It's like we're copying the whole texture into the frame buffer every frame, which actually, if I think about it, okay, it's coming together. I'm having my like Sherlock brain moment. We're uploading every single frame. So if we're uploading one of these textures into the wrong address, and if you think about it, this is actually probably the bottom of the frame, potentially. And the fact that it's flickering, this is like an interlaced thing, right? We're uploading this texture to the wrong spot. We're doing an illegal upload. So this is almost certainly down to how we're managing VRAM. So we have this VRAM slice. Where is it? We have our VRAM slice. We allocate to it. VRAM alloc. Okay, so I'm gonna log debug. VRAM after frame buffer allocations, VRAM head. After frame buffer allocations, this is going to be VRAM head. Okay, and we're just going to print this out. This big number, this big old number. So then we're going to initialize our context with our VRAM. Okay, so let's maybe when we test entry. But interestingly, this is only the tile set, like this isn't the tile set we draw in our first section, it's the one we draw in our second section. It's the one we draw in our second section. So this is the tile set from test edge. Where does this go in VRAM? Level VRAM. This is the other thing. So when we init, let's print it out. Let's say log debug let's also print it out here, level. Okay. What have we got? What have we got? Edge VRAM head, entry VRAM head. 35. That feels reasonable. Oops. What's the last number? 2? 2. Okay, max equals 4 times 1024 times 1024. Okay, so we haven't exceeded the end of VRAM and like wrapped around, because if we have an address that's too big, we will literally just wrap around back to the start. So that's okay. I'm pretty sure if you keep writing to VRAM, you're just it's just gonna not acknowledge the upper bits exist, and you're gonna wrap around. So that's good. So this seems like a real address. Are we uploading it to that address for 100% sure? Okay, so if I go into test edge, and we're in our draw function, upload, so the upload function just does it, and it uses the VRAM address. VRAM addr is VRAM alloc. Log debug. Tile set VRAM addr. Okay, what do we get? What do we get? Which again seems fine. Right? So this level, and this one is okay. Weird. What if I just stop? What if I just stop drawing stuff? Right? Does it work if it's just this one thing? Is that okay? Yes. So nothing here. We've still got the other level here. We've just stopped drawing it. What's the full region the frame buffers occupy? It is 0 up until this. Right? Starts at 0, runs until that. So the frame buffers start at 0, right? It feels kind of weird sometimes using address 0, but like this is literally just the dumbest rasterizer ever. Address 0 is completely valid. Also, let's just stop doing this for a sec. Let's stop decorating. Test entry, test load. Let's just clean this up a little. Okay, this is better. This is better. So, okay, edge. If I come back in, for one thing, let's just draw this from garbage VRAM and see what it looks like, because we could end up drawing. What would be interesting would be to see if we could get like a feedback loop going, you know? Like, can we draw these two things at the same time such that it like pulls, if it's drawing to the frame buffer, we should be able to find a weird situation where we can like make that look weird. Yeah, it's as soon as we start doing that. Is it something about the tile set itself that's garbage? And it shouldn't be. We should get flickering red now, which is fine. Okay. 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 For region the frame buffers occupy. Yeah, it's so it's uploading this into VRAM. Now, here's a fun thought. If I only upload this once, the only annoying thing is that upload has to be called inside of a draw frame. So let's do it like this. Static let's only call this once. And now we'll see more interesting oh yeah, the tileset data is literally just after the frame buffers. This is a good point. Maybe my alignment is wrong. Maybe I need to align more. Maybe I just need some padding. So if we only upload once, right? But this is weird because you would expect this to get, like what we're drawing from, to get nuked by the frame buffer, or you'd expect it to like change or something. So let's go back to drawing a bunch of garbage in the background. Let's so we should see, like, surely these tiles will change if it's using an address in the frame buffer. Surely drawing stuff to the frame buffer in these regions should change the tiles being drawn. This is the only thing that's still confusing me at this point. Why are we not seeing like weird feedback loop flickering garbage? But yeah, okay. So here's the other idea. Let's just put some random padding, right? Let's. But no, hold on, because the other thing. Which one do we load first? Which one do we load first? Or we do load Edge first. Okay. Okay, let's put some padding. How much do we pad by? VRAM. Let's add a function for this. Let's say int VRAM pad to some alignment. Does this mean that we're not actually allocating enough space for this thing? Ugh, that's really annoying. Okay, anyway. I'll except there's a Z buffer in the way. So really, how are we, unless our Z buffer is not taking up any size? Log debug VRAM alloc. At u let's print a little bit more stuff. That's always going to help. And that's just going to be this. And we can probably actually just call VRAM pad in here. But we won't for fun reasons. Except we don't need that. And we should check that we don't overflow the head. If v head greater than v... Oh, whatever, that's okay. That'll be fine. That'll be fine. So what happens if I make now? Control reaches end of void function, returns 0. Okay. So first off, let's see what it says about this Z buffer. VRAM alloc 0. So this is our first buffer, this is our second buffer. And our Z buffer, 1, 2, 3, 4, 5, 6, 1, 2, 3. Why is our Z buffer 5 times bigger? I think we've got a problem here. Because our frame buffer is like 100,000, 1 million, sorry, bytes in size. That's okay, because it's a 640 by 224. Actually, this should only be half the height, right? But this PSMZ, multiplied by 2. So it really should be smaller. It's the same dimensions, but it should be smaller. But somehow it's 5 times the size. That feels incorrect. How did this happen? Break, 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 break. That's okay. So we have the number of things multiplied by 2. Let me do this with a Alcredi Python 640 by 448 by 2. Oh, hold on. 500,000, 1 million. No, sorry, that is okay. That is double. We're fine. We're fine. Crisis averted. Crisis averted. That's, I can't read orders of magnitude at a glance. So we go from here, we add this, that checks out, these numbers look okay. But weirdly, if we don't upload this every frame, it's fine. Like that's the thing that kind of bugs me about this. It's definitely like an interlacing thing. Okay, so I'm gonna put a function. I'm gonna say VRAM pad VRAM, and I'm gonna pad it to like 2048 maybe, and I'm gonna go back to our adjacency thing and start uploading. Every frame again. Okay, so how much do I have to pad VRAM before this stops breaking? Maybe to 80, what is it? 408112. Well, actually, the next cool pads like aligns it before it does anything, so we can just put whatever number we want here. Okay, so what if I do 20,000 8192? Yeah, it actually doesn't matter in this case. It actually doesn't matter, which is kind of funny. Does this actually change where we're allocating from? Maybe 3537152. But see, this is so this tile set's getting loaded into a later spot. We can move this across the screen, it appears. So that's good? Bad? I don't know. I don't know what this means. What if I move it 50,000? Okay. Moves it even more. So it feels like we're going to have to move it like quite a way before we get it anywhere we want. Quite a way. So what the hell is this? How is this happening? For one thing, I'm just gonna, like, as a test, just see what happens if I divide all these things by 2, because, like, we shouldn't need... Yeah. Okay, that's, something. Now it looks like more like the kind of frame buffer corruption I was expecting if we're overriding things. Okay, okay. Because we only need half-height buffers, right? We're interlaced. Our internal resolution is only 224 pixels high. We only draw alternating fields every draw call. And now they just like disappear. Now we're fine. Okay. What is this? Here we load it again. VRAM alloc 1530. Is this where it goes the first time? I need to jump less. Or I need to stop spamming the logs when my player jumps. Seems to be a dead area. Yeah. But weirdly, as I move around, it goes away. So when we load the level edge, the head is 2813952. Okay, and it's always going to be that for that actually. Entry, it's 1433600. So let's see if I go over here, we load another level, gets loaded over here. Now if I come back, for entry 144, that's a different head, 1499316. 1433600. I don't think I'm resetting the VRAM head. Context free level. Yeah, I'm not calling X VRAM. This shouldn't matter though, but that's okay. VRAM slice reset head. Okay, so now it should go to the same place, and we should actually have consistent garbage as I move around, right? It's not going to reallocate things. This is unusual. This is not what I expected. Yeah, so now instead of this garbage moving every time a new allocation happens, it actually just stays there. The garbage stays. Weirdly enough, this doesn't impact the actual drawing of the tiles. This just comes down to the upload behavior, which is weird because if we're uploading to part of the frame buffer, you would expect that upload to impact how these tiles were drawn, right? You would, if this is part of VRAM, if this is part of our frame buffer, you would expect whatever, like as we overwrite part of the 2 tile with what's here, you would expect that to modify the number 2 tile. But if we stop uploading every frame, this just stops being an issue and the tiles draw fine, which is kind of a bigger issue in its own way, right? So what could be causing this? And it's cool that it works. It's cool that we can load new levels dynamically. I like this a lot. But this is just very, very unusual. Oh, Bobbius puts it well. This is really weird. I agree. I really agree. So let's draw a picture. This sometimes helps, right? This sometimes helps. Sometimes it doesn't help, but sometimes it helps. So we're going to do it. So we have a frame buffer, right? And it's a narrow frame buffer because it's interlaced. And we have a second one. And then we have a Z buffer as well, which only takes up a fraction, half the memory, I guess. So we'll call this FB1, FB2, and ZB, right? And this is our VRAM. Okay, so this is 0, this is like A, and this is B. And then we come in here and we're like, okay, oh my gosh, it is getting windy outside. Like this is the remainder of our VRAM, right, after our buffers. And we're going to cut this in half. We're going to say this goes to level 0 and this goes to level 1. Do with it as you please, okay? But for some reason, the things that are going in here, like not the first level, not the one that comes immediately, after VRAM, but the things that come in here is somehow overriding part of either this or this, I can't tell which one, and causing this flickering. However, it's only the upload. When we draw, this isn't actually impacted. So this seems to be a one-way street somehow. So this could mean that our upload is doing too much work. It's uploading too much data somewhere. Does VRAM get locked / inaccessible during VBlank? No, I don't believe so. I don't think that is a thing that happens on the PlayStation 2. I don't think that really makes sense for how the PlayStation 2 circuitry works. Potentially. It might. That's a good point. Look, it's just so common for games to do so much work in between frames that I don't think this is the case. Also, I wait for VSync, so as long as I get everything done within one frame, I should never really be trying to do anything during VBlink, I wouldn't think. Anyway, even if it gets locked, because we're using DMA transfers, the DMA controller should, I believe, just respect that and block. I think that's how the DMA stuff usually works, right? It understands what can go where, and it can stall based on various things, and you can set the DMA controller up to have like multiple things in flight, and if one gets blocked it swaps to the next and whatever. So I don't think this is a concern. I don't know exactly how it works, but I don't think it's a concern. What is concerning to me is that it's the second level, right? If it was this one, it'd just be like, oh, okay, somehow this overlaps, right? There's overlap here. But this thing just should not overlap. Okay, so let me show the bizarro behavior again, because this is really, really strange. Actually, hold on. Now that I've resized my buffers, it's actually this thing. So let me go back to my adjacent test and let me re-put this in here, right? And let me do this. Let me just put it in this one for now. Okay, this lessens. No, that didn't change anything that time. I need to swap my scene. Okay, so let me put this same thing in my other code. So instead of uploading every frame, we only upload once. And this isn't correct, right? This doesn't actually hold water for doing things longer term and longer term resource management. But we're going to have this little bit of state to track if things are resident. And if it's already in memory, okay, so this is different to how it was behaving before. That's very unusual. That's actually more strange. Oh no, hold on. That was the wrong... I keep doing the wrong level. Okay, that's okay. That's okay. This. It actually is going to make a difference. Static and resi. Resi in this case meaning resident, right? Is it resident in VRAM? Okay, that's what I expect to happen, right? Because if this is somehow being mapped into one or both of the frame buffers somehow, then whatever ends up in this frame buffer, e.g. if we clear the screen, that's what we're going to draw from if we're not refreshing at every frame. So this is actually suddenly consistent with how it should be behaving. So that's good news. That's very good news. So now we just need to look. Our entry level, entry, the VRAM is here. So actually, here's the other thing as well. If I go to the right, this one now works. This one now works. That's good. That's fantastic news. This is, sorry, ignore the tile garbage. So, as I cross the level load threshold, the first time, because it doesn't actually track any state. Okay. I think I'm getting a picture here. So this overlaps with one or more of my frame buffers. 1433600. So this starts at 1433600. I need more room. Okay. It's happening. It's coming together. So I think I need to draw a more detailed VRAM map. So this is what's in VRAM. Okay. Our first frame buffer goes at, where is it? 0 to 573440. Our second frame buffer goes from 573440 to this plus itself, which is 1433600. 1146880. That's actually not that hard to do in your head. 1146880, my mistake. Okay, and then the Z buffer is gonna go from 1146880, 1146880 to 1. Oh, that's harder to do in my head. 1146880 plus 286720 is 1433600. 1433600. Now, level 0 is going to start at... Okay, here we go. Entry starts at 1433600. 1433600. So this seems like a bit of a problem, okay? Likely, if we tried to do anything with a Z buffer right now, it wouldn't work. And this might actually explain some past issues I've had, potentially. So level 0 starts here, and then level 1 is similarly gonna be at... where is it? 2813952. 2813952. Okay, so 1436660. Now, what's the max VRAM we can have as well? Max is 4 times 1024 times 1024, and that is 4 times 1024 times 1024, 4194310. 4194310. 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, 4, 5, 6, 7. So we're a quarter of the way through VRAM. So there's no chance that we've wrapped around back to the start of a buffer here. That's good to know. Is it possible that one of our functions is just not uploading to the correct place? Is this a possibility? It doesn't seem entirely unlikely, right? So upload texture, which uses the VRAM address, and bind texture also uses the VRAM address. Let's check in with our core library code. Bind texture, VRAM address, width, height, PSM. Okay, that's okay. Upload texture. For some reason, this still lives in draw 2D. It's actually not. What was the answer? Not really a problem. Not a concern here. This is overlapping VRAM. I don't think it gets locked, but even if it does, because we're doing everything through the DMA controller, the DMA controller should respect that. So it shouldn't matter. I don't know a direct answer, but that doesn't seem like the problem here. How are you going, Stranger, by the way? What have you been streaming? What have you been working on? I see you've got a cool check mark. I don't remember if you had that before. How did you get verified on Twitch? What happens? What's that process? So we upload a texture, we have, and the VRAM address. So we should be using the same VRAM address for all of this. I think I need to enable trace logging. This is going to be extremely loud. Main log level trace. So let's run this. We're going to have to clean everything and then run run.log. We're going to get a trace log of everything going on. Hold on. I don't know if we actually got through a whole frame. There we go. Okay, so that was good. You could actually see that happening slower. So this is, for people who haven't seen it before, this is trace logging in my library. It's very, very detailed. You can see everything we're doing. Every write we do to a draw buffer goes through here. So binding texture address this. That is the texture we kind of expect, right? That's the level 0 texture of 1433600. Oh, okay, verified's just a Twitch parter. That's cool. It's not like a magical like shake hands in a back alley kind of deal. Haven't streamed since January. Nice. What, if you don't mind sharing, what startup or what kind of startup are you working for? That sounds exciting. Also, I would love to filter out the start of these lines. So let's maybe, let's go up to the start of where we start doing things. What is this? What do I do here? How do I filter out? Bash log filter ANSI color codes, or at least show it with the color codes. How do I, oh gosh. I mean, I can actually probably just run this in Vim directly, right? Can I? No? Not a real command, that's okay. Trace debug. Well, I like that. It's a PlayStation 2. Resources are really scarce. No, I really like that info, trace, debug, and error, like ERR space, I don't know, or ERRO. Like, I like having the same number of letters. So I guess I could do info with a space and then trace, debug, and I guess error is 5 letters as well. Maybe, yeah, EWIDT. That also makes a lot of sense. That actually makes a lot of sense. That might be even better. Remove ANSI codes. Yeah, these. How do I get rid of these? This is the same thing that I had before. Does sed do this better than Vim does? Is that possible? Apparently it does. Okay. Vim didn't like this. Sed, no problem. Sed says hold my beer. Okay, so this is all the PS2 SD, the PCSX2 startup. This is my code. Allocating frame buffers. This is all good. This is what we were doing before. Using frame buffers, the most useless trace log I've ever seen. Setting up the fields. So these are interesting, right? Because these are the addresses divided by 4, basically. FB0, 57344012345. Yeah, so this is the address divided by 4. And this is how the graphic synthesizer deals with them. It tells you hit that line of code. Yeah, that's why it's there. Less dash R. Less dash R for color codes. Is that real? Oh, that's beautiful. Holy shit. Holy shit. This is the nicest thing I've ever seen. Okay. So, level bump allocator. Oh yeah, I forgot I put this trace here for when we do this bump allocation. That's good. That's good. Screen dimensions. Okay, VRAM head. So this is what we have here, 2813952. Okay. Similarly here, VRAM alloc here for this size, aligned with this VRAM address. The tile set address is the same as this address, which makes sense. Thank you, Stranger, for that tip. Less dash R. That's good to know. I know that somewhere in my brain, but I always forget it when it comes time to use it. Okay, so let's go to line buffer, blah blah blah. This is extremely invaluable output. It's just very, very loud. Uploading texture from this address to 1433600. 1433600. This is the area of VRAM we're allowed to use. That's all good. I don't know what the big deal is. 43. So, okay. One thing I'm noticing is set fields 143360. So, funnily enough, this feels fake, right? So 573440 divided by 4 is exactly this address. That feels fake, but I love it. I love it. It's because we're doing very regular allocations, right? So actually, what happens here is the VRAM address, as the graphic synthesizer perceives it, of this frame buffer is actually exactly the same as the emotion engine side VRAM address, right? The non-bit shifted address. So what's probably happening is we're not bit shifting this properly when we upload the texture. If we go into our system hardware manuals and we look at our GS user manual and we look at the field text-O, this is the field that stores texture information settings, okay? There's two variants of it because we can have two drawing contexts we swap between. Texture base pointer divided by 64, okay? 3, 4, 5. In other words, right shift by 6 bits. So if we don't do that right shift properly, there's a chance that we're gonna put something in the wrong place. So when we upload a texture, okay, VRAM address. Do we bit shift the VRAM address? TRReg, TRX dir. Okay, so where does VRAM adder come in? Divide by 64. We do that properly in the upload, allegedly. Bit buff. This is my other favorite register. BIT, BLT, BUF. Really, really cool register. Transmission between buffers. Base pointer, word address, yes, okay. Buffer width, unit of pixels divided by 64. Width divided by 64, okay. So this is correct. What about bind texture? State text VRAM adder. So when we draw a thing, we do this, active text equals this, text VRAM adder divided by 64. That's correct. I don't get the big deal. I don't see what's going on here. I don't get it. That looks correct. We're not using this without dividing by 64. And we're not pre-dividing by 64. Active text, that's okay. So what about active text? That's fine. We only use that to check our state. What's going on? Ask ChatGPT. Call is stupid. Don't use it. Lots of these commands for doing this are silly. Ask ChatGPT. ChatGPT is so useless for PlayStation 2 stuff, it's not even funny. I know this is a joke, but it's just worth saying because someone was suggesting in Discord the other day, like they asked ChatGPT to write a PlayStation 2 soft float emulator, and they posted the result, and the result was just garbage. ChatGPT can't do it. There's not enough examples to learn from. It's just my code. It's just me and a few other guys. You know, that's not enough to train an LLM. It's not ingested these system hardware manuals. Bobo Chid Brew, welcome. Hello. Thank you for stopping by. First time chatter. Good to see you. We're currently in PlayStation 2 VRAM hell. It's not a fun place to be, but hopefully we're gonna work it out. We're gonna work out why. Like, this just feels too good, right? The fact that this is 4 times this. That has to be the problem, right? That has to be the problem. I just don't understand how we override part of this buffer. I don't get it. Oops. The other fun thing, I guess, is when we run this with trace logging, we can actually see the first few frames come out. So you can see the actual process where it's like, okay, I'm drawing this, and then I'm drawing this based on what's in VRAM, and then I'm drawing nothing because it's like this feedback loop. Have I tried turning it off and on again? Actually, do you know what would be interesting is running this on a real PS2. Unfortunately, I can't show that on stream, so it's not very entertaining. But it would be cool, because sometimes this VRAM stuff is a little different. How do I make PS2 games? Simple view of the process, which tools I use. Yeah, so I'm plugging it back in. There's no real PlayStation 2 involved in this process right now. How do I make PlayStation 2 games? So there's you have to write a lot of really gross low-level C. There's a library called PS2 SDK that does a lot of heavy lifting for you. There's a toolchain called PS2 Dev, so you just compile normal C code. It's a virtual console. I do run things on the real PlayStation 2 as well. I've got one. I've got to unplug it, but I do like have a PlayStation 2 just behind my monitor, like it's here. I do hardware verify sometimes. I actually hardware verify often because it's really easy to write stuff that runs in the emulator, but not on a real console. But yeah, so for all my stream testing, I do emulate. However, I would very much like to buy a better capture setup. and I'm trying to raise a bit of money to do so. So if you do feel like donating, I have an anonymous donor so far. Obviously no pressure, but this is something just so that I could level up my stream. I can't really justify the expense right now. Compile a specific target and use a PS2 API. Yeah, pretty much. I wrote my own graphics driver because I didn't like the one that comes with PS2 SDK. So I, wrote a lot of bit manipulation code. So there's a lot of code that looks like draw buffer. Looks like this, right? Where I'm just putting stuff in buffers. My website link in my Twitch bio is broken. That's not good. But yeah, so basically be confident with C, because if you can't write C code, you're gonna have a bit of a problem. It's missing the thing that tells it to not be a subpath. Thank you. Setting direct commands to GPU. Yeah, it's not even really a GPU. It's more of a rasterizer. It's a thing that puts triangles on the screen sometimes if you ask it very nicely. It doesn't work the way a traditional GPU does. So there's a lot to learn about how this thing works. It's not an easy undertaking, but it's very, very rewarding if you put the time in to really learn about how it works. And Bobo should brew. Thank you very much for the follow. I do really appreciate it. We're getting close to 800 followers, which is really exciting. Also, I've got some Twitch emotes in the pipe. Boboch. Perfect. Thank you for the clarification. I get some very interesting names in this channel, so it's always good to know that I'm saying them correctly. Okay. Is there a chance that I've really messed something up in a really, really stupid way? No, I'm dividing by 4 here. Why am I dividing by 4? Because the GS fields are different. The addresses are different, I think. Is it possible? Is it possible? He did the coffee thing. Okay, hold on. I might have just fixed it. He did the thing. Oh my gosh! Thank you so much, Stranger. Holy shit! Wow. Sorry. I don't have any like alerts or anything, but that is incredible. That was. Hold on. Let me just. That was not what I expected. But yeah, so we're gonna get a capture card. We're gonna level up this stream in the PlayStation 2 dev. That's so exciting. That was $131. Incredible. 131 Australian dollar dues. You're going on the Hall of Fame. Are you in my Discord, Stranger? You should be. You get a special role for being a donator. Yeah. Cool. Just point my camera at the CRT. That's the dream. There's a streamer. I've seen streamers do this. It's really fun. There's a Kingdom Hearts streamer that did this, and like CRT streams are pretty cozy. Dick sword. Is this Twitch lore, Twitch meme that I don't understand? But no, seriously, man, that's huge. Thank you so much. I'm looking forward to getting something nice for the stream. Okay, log level debug. So this kind of incredibly I think okay this has a really funny solution. Really funny solution. My code was fine. My code worked. Once you compile it, you get a ROM file. So yeah, PS2. So PS2s have been blown open for a really long time. I use a hacked memory card. You can hack your PS2. You can soft mod it with just a memory card. Discord. I really need to set up this bot. I've got a few things I just keep meaning to do for this stream that I never get around to. But yeah, so hacked memory card is the way to go. And you can just like run random programs from a USB or from the network. I run my games over the network. I do support building disk images as well. Oops. Oh my God. But disk images are a bit harder to wrangle. ISO file formats, ISO file systems and stuff. There's all kinds of weird stuff to deal with. Okay, so the thing that broke here, the thing that was going wrong, and this relationship was the thing that clued me into it, okay? When I was setting my frame buffers, I was dividing them by 4 to get the GS address. But I don't know why I was dividing them by 4, because the way the graphic synthesizer deals with these addresses, it always divides them by 64. It shifts them 6 bits to the right. The lower 6 bits essentially just have to be 0, which is fine. But so instead of dividing by 64, somehow, for some reason, I was dividing by 4. And I think this is probably an example of bad copy-paste. Like, I probably was dividing by 64 somewhere in my code at one point, and then eventually I was just dividing by... I like miscopied it and was just dividing by 4, and then I've obviously copied this from my PlayStation 2 roguelike into this. So that's amazing. So in conclusion, my code works and everything's fine, and I can probably swap back to using less ugly tiles if I really wanted to. Let's in fact do that. Let's go back to Edge. Let's grab just my normal tiles, and this should be okay. So we'll have ugly tiles on the edges, and then ugly tiles in the middle too, because we don't support different tile sizes. We don't support different tile set sizes. So there's one more thing I need to do, which is in draw.c. Okay, so where do I tell the code the size of the tile map? I mean, in put tile, it's kind of obvious, right? Tile square. It has no GPU. It doesn't have a conventional GPU. It has a thing that does texture mapping. It has interesting hardware components that do 3D. If you want your head to spin, go read the Wikipedia page about PS2 hardware. It's very unusual. I'm going to do a YouTube video. I want to do like a 30-minute lecture where I kind of just talk through the process of how something goes from 0 to pixels. Maybe I should even do a long-form YouTube video where I build a simpler version of my graphics driver from scratch and like start with nothing and just put bits in the buffer to show how a triangle gets drawn, go from 0 to triangle just with like the barest code possible. That could be fun. And I feel like that could get views as well. I feel like, that's ultimately my goal, but that could be fun. Tiles per column. We don't need this. Okay, so now when we call put tile, we can pass a thing, and in the tile map, let's put it here. Let's just say tile square. Let's just pass it in as an extra argument. Extra arguments are fine, right? There's nothing goes wrong when there's extra arguments. Join my Discord. If you want to get updates on my stuff, join my Discord. That's the place to be. Because I have 2 YouTube channels. I have a VOD one and a non-VOD one. The non-VOD one is very neglected at this point. Tile square. Okay, here we go. So now when we come in, we've got to update the headers as well. We're going to say put tile float, and nice. We're gonna indiscriminately mix resolutions. This is good. Our tiles are going to be the same size, but our tile maps don't have to be the same size, because the player collision code assumes that everything's 16 pixel aligned. That's fine. That's all normal and cool. Okay, so now in my test levels, I just need to come in when I say draw tile map. This is an 8 pixel, and I can actually just say 8. C does that for me. This isn't Rust. I don't need to put a decimal point everywhere. Test. Load, I come in and I say this is a 16 by 16 tile map, and then test entry, this is also a 16 by 16 tile map. Okay, so now when I run, this is going to work, and I'm going to see all my normal tiles. This is still ugly as hell, but then you come into this part and it's like, we have nice tiles again. Things look nice and normal and good. And then I go a little bit further and it loads this other disgusting tile set back, but it's nice to test. It's nice to know we can test like this. So load tile sets. We can potentially have an infinite world if we keep swapping out additional levels. Content authoring is going to be awkward. We're going to have to put some thought into that, but this is really starting to come together. So you can see in my logs as I move back and forward, we load data. Now, the real test is, can I get rid of this, right? Can I upload these textures every single frame, which is wasteful, but it's actually not uncommon on the PlayStation 2 for games to be uploading all of their textures every single frame, because VRAM is so small, especially if you're in progressive scan. You only have, like, if you're 640 by 480 progressive scan, so non-interlaced, right? Full frame buffer size, you maybe have 2 megabytes of VRAM left to work with. You use probably about half your VRAM. In our case, because we're interlaced, we're using about a quarter of VRAM. But that's still only 3 megs, and it would be really easy to blow that out with texture data. So if you want to draw more than 3 megs of textures per frame, you have to upload more textures mid-frame. There's no way around it. The cool thing about this is it actually means we could allocate overlapping textures, and as long as we upload them right before we bind and draw them, in other words, right before this thing, then that's fine. Every level could actually, like, our 2 level slots could both use the same region of VRAM. As long as they upload all of their assets before they get drawn, we can just indiscriminately draw. That's fine. And this is a really cool benefit of building things like this. This add and then load still has this resident block. And this was just useful for troubleshooting, but this should just work now, right? We shouldn't have any more of this weird overlapping VRAM stuff, and we don't. We don't. Can DMA run in parallel with the CPU? That's the point of DMA. That's the real advantage. So you kick off a DMA transfer, the CPU keeps doing stuff. It's never as simple as yes or no. If the DMA is reading memory, then your CPU and the DMA are going to be in contention for memory. But as we talked about earlier in this stream, I think before you got here, there's a special area of memory called scratchpad, which I think is 16 kilobytes. And the CPU can read that region of memory while the CPU is reading, like the CPU or DMA, right? Like they can be read at the same time. You don't get memory contention there. But yeah, so you still have to worry about normal memory contention. If you're DMAing from the vector unit interface to the graphic synthesizer interface, no problem at all. The CPU kicks on and it's very happy. The DMA has a bunch of different modes for how it deals with stalls or like blocks. So if it tries to read memory but the CPU's reading it, maybe the DMA controller's smart enough to say, hey, I've got another transfer banked up here. I'm going to start sending something to the graphic synthesizer from the vector unit, and then when I can read memory, I'm going to try and do that again. So the DMA controller is very programmable and very flexible. It's a really incredible piece of kit. It's the heart and soul of everything happening on the PlayStation 2, right? So yeah, basically, you kick your... And the other fun thing, and I kind of want to talk about this in my video too, right? You start a draw, you kick geometry off to the vector unit. While your transform is running on the vector unit, you can actually while that transfer is running even, you can interleave data, like geometry data going to the vector unit and texture gut data going to the graphic synthesizer. So while those two things are happening, one from main RAM, one from the scratchpad, they can be happening in parallel. And then your transform, you do your like camera transformation and stuff for your geometry data, and then you start drawing it. But as your textures just have to be in VRAM by that point. So you can actually, if you understand the timing well enough, you can kind of synchronize these things to the absolute like microsecond, to the nanosecond. You probably want to be uploading the next textures while that first draw is finishing, as long as, it's tricky. And I think my approach of segmenting VRAM into 2 different parts and having like an A part that you're drawing against while you're uploading into the B part is probably the way to go. But again, I don't understand VRAM contention well enough. I'll need to benchmark, and I'll have to build complicated things before I can benchmark. But this is kind of like a baby stepping stone to get there, which is nice. I think that's pretty cool. And you can see we're only using less than 4% of the graphic synthesizer to do this. 50% of our CPU somehow. I imagine quite a lot of that is just waiting on VSync. DMA means you don't have to use the CPU itself. Yeah, okay. Same bus. A faster way to copy memory, yeah. But it's always like a parallel component, right? It's just, yeah, if it uses the same bus to read memory, like... I guess that's the question. The PlayStation 2's interesting memory bus layout is what makes the DMAX so cool and exciting. Or a way to read memory the CPU can't access, which in this case it's both, right? It lets you copy things to memory that lives outside the CPU, and it lets you do it very, very quickly. Very, very quickly in the sense that it happens in parallel. Cool. But yeah, it does make sense in some cases that a DMA controller would kind of like pause the CPU while it ran. But also if that's an explicit pause or kind of an implicit one because of memory contention, you know, there's a million different hardware configurations where that's the case. Okay, this is cool. I want to start making some actual content soon, hopefully. My player character is working really well. You can see there's a little bit of stutter maybe. I can feel it when I try and load another level, but that's okay. And the smarter we get, the better this will be. The only thing left to clean up here is the fact that our TGA, we just call calloc for our pixel data here. So we need to use our actual level allocator, and we can just pass that through. That'll take, I probably do that off camera. Details vary greatly both in time difference, yeah. Okay, this has been a fun stream. We got some stuff done. I probably need to go because I've got people coming over tonight and I'm teaching before then, so I'm gonna have a little quick lunch and a panic clean. And we're gonna throw the love on and find someone cool to raid. So let's do it. Let's do it. Thank you everyone for tuning in. Thank you for the great questions. Thank you. What did you? How did I say I pronounced your name? I forgot. I'm really sorry. It's just Boboch, and Stranger, of course. Wonderful to see you. It's been a little while. Good to hear you've got a startup job. I'm thinking of maybe taking a job and topping up my coffers. Because, yeah, the part-time teaching thing it's fun, but maybe it's time to go back to normal full-time work. Story touch-ups, avoid enemy models. What's something cool? Who's someone building something cool? I'm always happy to take recommendations. Stranger, I feel like you might have some good recommendations for a streamer to raid. Always happy to take it. Stream dev. Always happy to find someone cool. I like looking for, you're out of touch. Yeah, me too. I used to watch more streams, but man, I feel like you either stream or you watch streams, right? Or neither in your case at the moment. You get busy with life. Godot game dev. I do love a bit of Godot. Nobody online. Same actually. I don't normally stream at this time. Blender 3D modeling. Let's check this out. Solo game dev. This is in, I don't know what this is. Let's raid this. Kelvin Shade. Let's see what they're doing. Oh, Dance of playing NetHack. I'm gonna look for another developer. But playing NetHack is pretty close to being a developer. It's the closest to writing code you can come to, or the closest to work you can come to while you're playing a game. I love NetHack. I've never actually played it. All right, thank you so much for tuning in, everyone. Thank you again, Stranger, so much. I'm very excited to be trying. I'll get my hands on a capture card soon, and that will be wonderful. That'll really level up the PS2 dev experience. And let's go share the love around. I'll see you all next time. Bye.